Hello children, welcome to 9th Chemistry online classes. Chapter 4 Structure of the Atom. So today we will discuss the exercise part in your textbook. Exercises page number 54, 55 and 56. So all the exercise you can write in your notebook. Some answers you can write in your textbook, that you can do in your textbook. Other things you have to write in your notebook. So in your notebook, write exercise and write the page number also and write the first question. Compare the properties of electrons, protons and neutrons. So property, electron, protons and neutrons. So first charge. Electrons have negatively charged, protons positively charged and neutrons no charge. Next is location. Electrons revolving around the nucleus, located within the nucleus, located inside the nucleus of an atom. These both answers are same. And weight. Mass is negligible. Electrons mass is negligible. Protons 1 AMU, 1 atomic mass unit, and neutrons also 1 atomic mass unit. Second question. What are the limitations of J.J. Thomson's model of the atom? Answer. J.J. Thomson's model says that the mass of an atom due to electrons and protons which are evenly spread throughout the atom. But this did not agree with observations of Rutherford, according to whom the mass is concentrated in a very small space, later called nucleus. Okay, so in J.J. Thomson model, both charges or electrons and protons, they are evenly spread throughout the atom like watermelon seeds in watermelon or raisins in a cake. But Rutherford experiment, it shows that nucleus or the center part is concentrated in the center, middle part, that is called nucleus. Mass is concentrated in the center. And Thomson's model of the atom could not explain the results of alpha particle scattering experiment carried out by Rutherford. Okay, so by this Rutherford experiment, alpha particles come back because when it reaches that is middle portion, the center portion only. So there only the positive particles or nucleus. So write this answer in your notebook. Third question that we already did in our notebook. So fourth question. Describe Bohr's model of the atom. So I'll just put some points here. I'll read the first one. An atom consists of a small positively charged nucleus at its center. Second point, the whole mass of the atom is concentrated at the nucleus. Third part, the volume of nucleus is smaller than the volume of the atom. Fourth point, the protons and neutrons of the atom are present in the nucleus. The fifth point, the electrons of the atom, which are negatively charged, revolve around the nucleus in definite circular paths known as orbits, or which are designated as K, L, M, N, etc., or numbers as 1, 2, 3, 4, etc. outward from the nucleus. Okay. Then sixth point, as each orbit is associated with a fixed amount of energy, these orbits are also known as energy levels. Okay, discrete orbits. While revolving in discrete orbits, the electrons do not radiate energy. So these all points you have to by heart, because these all points are very, very important. By learning these points, you will get that idea about Bohr's model, and you can draw the model also. Okay, so write that answer in your notebook. Fifth question. Compare all the proposed models of an atom given in this chapter. So you studied in this chapter 3 models: Thomson's model, Rutherford model and Bohr's model. So we'll see. First point, sphere is positively charged as Thomson's model. It is a positively sphere. and negatively particles are evenly distributed. And Rutherford, the nucleus is at the center and is positively charged, holding the entire mass. The entire mass is concentrated in the center, that is the positive part. And Bohr model, nucleus is present at the center and is positively charged. So Rutherford and Bohr, both points are correct, but in this time, yes, both points are correct. Both points are same. Okay, children. And next one, Thomson's model. Electrons are negatively charged and scattered all through the inside of the sphere. Here it says the location of electrons. Electrons are evenly distributed. And in the case of Rutherford, electrons are negatively charged, revolving in a well-defined path. And Bohr's model, electrons are negatively charged, revolving around, but do not radiate energy. That is the difference of this Rutherford model and Bohr's model. Because Rutherford model, he couldn't explain the stability of the atom. But here, Bohr's could explain. Why? Because these electrons, they do not radiate energy and they have the stability. Next point, Thomson's positively charged particles. Number of positively charged particles equals number of negatively charged particles. In next point, Rutherford. In comparison with the nucleus, the size of the atom is very large. Next point, Bohr's model. The distinct orbits are labeled as K, L, M, N, etc. And here also one point, Thomson's model. The net charge in the atom is 0. That means positively charged particles and negatively charged particles same. So numbers are same. So that is net charge is 0. So you can make these 2 points as 1. Okay. So that also write in your notebook. Sixth question, that is summarize the rules for writing of distribution of electrons. So that no need to write that rules, that you can read in your textbook. So seventh question, define valency by taking examples of silicon and oxygen. So valency, definition of valency is defined as the combining capacity of an atom of an element. And we take some examples. Silicon atomic number is 14. So electronic configuration or distribution of electrons like that, K, L, M. So K shall contain 2 electrons, then L is the maximum capacity 8. So 8 plus 2, 10, then 4 more electrons, that is in the M shell. So here this 4 is the valence electrons. The electrons present in the outermost orbit are called valence electrons. So here 4 valence electrons are there for the case of silicon. So valency of silicon is 8 minus 4, or that is 4. Okay, 8 minus 4. So how many valence electrons are there here? 4. That is why valency is 4. And next is oxygen. Oxygen has atomic number of 8 and its electronic configuration is 2 and 6. So here how many valence electrons are there? 6. So by getting the stability, it needs 2 more electrons for attaining the octet. So for getting 8 electrons, then only it get the octet. So it need 2 more electrons. So 2 is the valency of oxygen. So write this also in your notebook. Eighth question we already discussed. So we'll go to ninth one. Na plus has completely filled K and L shells. Explain. Na plus is a ion. Okay, that is an ion. And Na means sodium. So this is sodium ion. So sodium ion is completely filled and stable. Explain. The atomic number of sodium is 11. It has 11 electrons in its orbits, where in the number of protons is equal to the number of electrons. That means atomic number of sodium 11 means number of protons and number of electrons same, 11 electrons and 11 protons. Hence, its electronic configuration is K2L8M1. 2 plus 8, 10, 10 plus 1, 11. So that is sodium atom's electronic configuration. So that time it is not stable because the last shell or outermost shell, the valence electron number is 1. So by getting 7 more electrons or last shell 8 electron, then only that atom would be stable. But here only 1 electron, so which is easy to leave this electron to some other atom or take 7 electrons to here. This leaving 1 electron is easy. Okay, so this sodium atom leave 1 electron to any other atom. So what is the number of electrons now? K2 and L8, 10 electrons or 10 negative charge. And what about positive charges in the nucleus? That is 11. So 1 is more than this number of electrons. So which charge is more now? Positive charge, because protons 11 and electrons 10. So one positive charge is excess. That is why Na plus. Got it, children? The 1 electron in the M shell is lost and it obtains a positive charge since it has one more proton than electrons and obtains a positive charge Na plus. The new electronic configuration is K2L8, which is the filled state, that is stable. Hence it is very difficult to eliminate the electron from a filled state as it is very stable. So this answer also you can write in your notebook. So very important. 12th question. If bromine atom is available in the form of say 2 isotopes. So isotopes means same atomic number but different mass numbers. So 2 isotopes of bromine. One is bromine 3579. Okay, and this thing you can write in your textbook. 35, that is the atomic number, and 79 is the mass number. Write like this, children, in your notebook. Br, that is bromine, and here 35, that is the atomic number of bromine, and here is the mass number. So this is the one isotope of bromine, and one more isotope is there, that is bromine 35, but mass number is 81. So that is called isotope. So first one 35, bromine 79. So we can call like that. Bromine 79 is 49.7%, and bromine 81, that is the next isotope, is 50.3%. Okay, so bromine atom is available like this, these two forms. So calculate the average atomic mass of bromine atom. So sometime this much 49.7 and in some cases 50.3. Okay, the average atomic mass of bromine atom, how we calculate? 79, that is the mass number of bromine. 79 into how much percentage? 49.7%. So that is why 49.7 by 100 plus next bromine 81 into how much percentage? 50.3 by 100. Okay, so when we calculate this thing, we calculate this, we will get 39.263, and by doing this one we get 40.743. So by adding this thing, 80.006 mass, atomic mass of bromine. So one bromine actually it contains 2 isotopes. So the average mass of that 2 is called this much, 80.006 U. So this also write in your notebook. 11th question. The average atomic mass of a sample of an element X is 16.2 U. So one sample or one element, that atomic mass is 16.2. What are the percentage of isotopes X16 and X18 in the sample? So I'll just do this thing. See, X means this X means what? X16 plus X18. So this average atomic mass is 16.2 U. Okay, so that is the given, the 16.2, the average mass is given. So here we have to find the the percentage of, how much percentage of X16 and how much percentage of X18, that we have to find. See, so given value, first we have to write given value. Atomic mass of element X is 16.2 U. That is the full mass. Let the percentage of the isotope X16. So this we can take it as, that is Z. This we can take it as Z or any letter. And this thing X18 we can take it as 100 minus Z. So in the total amount 100 percentage, this percentage is how much, this percentage is how much, that we have to find. So one quantity we can take it as Z. So other quantity is 100 minus Z. Got it? Then atomic mass of X. This is atomic mass of X, that is 16.2 U. Okay, atomic mass of X. So just to do it, Z into, Z means this X16. Okay, so Z into 16U plus 100 minus Z into 18U, that is X18 by 100. And atomic mass of X, that is 16.2, that is already given value, so that is equal to Z into 16U plus 100 minus Z into 18U by 100. So we'll rearrange this thing. See, this 100, cross multiply this thing, so you will get 1620 U, and here Z 16 UZ plus 18 1800, 100 into 18, so 1800 U minus 18 UZ. This already you doing in the maths, in your maths, you are doing this type of calculations. Okay, then we get, see, 16 UZ and here 18 UZ, both are same thing, 6 UZ and here UZ, but this is negative, so we will get a negative UZ. But when it come to the this side of this equal, it will form 2 UZ. 2 UZ equals 1800 U minus 1620 U. This calculation you can do. Okay, so you will get 180 U, 180 U. So Z equals 180 U by 2 U. See, Z equals 180 U by 2 U. So you will get 90%. So this 90% means X16. X16, that is Z. X16 is 90%. X16 is 90%. So what is X18? X18 is 10%. Okay, so one is 90%. 90% is which one? X16. X16 is 90%. That quantity is too much, and X18 is only 10%. These two are the isotopes. Okay, children. So these are the answers. X16 90% and X18 10%. 12th question. If Z equals 3, what would be the valency of the element? Also name the element. So this kind of questions is very important. If Z equals 3, sometimes Z equals 7 or 9 up to 18 we can ask. Okay. So atomic number Z equals 3. The electronic configuration K2L1. So 2 plus 1, 3. Hence its valency is 1. and the element with atomic number 3 is lithium. So all of you by heart that elements up to 18. 13. Composition of the nuclei of two atomic species X and Y are given as under XY. Protons 6 protons X6 Y6, neutrons X6 Y8. Give the mass number of X and Y. What is the relation between these the two species? Mass number of X. Mass number of X, protons plus neutrons. How many protons? 6 protons. How many neutrons? 6 neutrons. So 12. Mass number of Y. Mass number of Y, how we calculate? Number of protons 6, number of neutrons 8. So 14. They are the same element as their atomic number are the same because their atomic numbers are same. They are isotopes as they differ in the number of neutrons and hence their mass numbers. Okay, so atomic number means number of protons and or number of electrons, and mass number means total of protons and neutrons. Got it? So this also write in your notebook. 14th one, for the following statements write T for true and F for false. First one, J.J. Thomson proposed that the nucleus of an atom contains only nucleons. And what are nucleons? Means what? The particles present in the nucleus, that is proton and neutron. They are called nucleons. So J.J. Thomson proposed that the nucleus of an atom contains only nucleons. So that statement is false because J.J. Thomson proposed that electrons are evenly distributed in the positive sphere. So that statement is false. Second one, a neutron is formed by an electron and a proton combining together, therefore it is neutral. That is also wrong statement. Neutron is formed by an electron and proton. So this neutron, electron and proton, these are the particles of an atom. So that statement is also false. Then the mass of an electron is about 1 by 2000 times that of proton. So that statement is true. The comparison of mass of electron and proton. And the fourth one, an isotope of iodine is used for making tincture iodine, which is used as a medicine. Okay, tincture iodine is a medicine, but isotope of iodine that is used for the treatment of goiter. So this statement is also false. So that you can do in your textbook. 15th one, you can choose the correct answer. Rutherford's alpha particle scattering experiment was responsible for the discovery of atomic nucleus, electron, proton, neutron. So this experiment responsible for the discovery of atomic nucleus. 16th one, isotopes of an element have. Isotope means same atomic number but different mass number. So the same physical properties, first option A, the same physical properties, that is wrong. Different chemical properties, that is also wrong. Different number of neutrons, different atomic numbers. So different atomic number is wrong. So different number of neutron, that is why it has different mass number. Okay, different number of neutron, that is the correct one. Number of valence electrons in Cl minus ion, chlorine ion. 17th question, chlorine ion, valence electron. Ion means what? That is the stable form and it has 8 electrons in their outermost shell. So what is the chlorine atom? 17. Chlorine atom atomic number is 17. So its electronic configuration is 287, and chlorine minus ion, Cl ion having 288 because it need one more electron to get the stability. So 288. So valency is 1. So here how many valence electrons are there? 7 valence electrons. Sorry, 8 valence electrons. 18th question. Which one of the following is the correct electronic configuration of sodium? 28, 821, 218, 281. 281. This is the correct form. So that is also you can do in your textbook. And the last question. Complete the following table. Atomic number, mass number, number of neutrons, number of protons, number of electrons, number of name of the atomic species. So atomic number 9. Atomic number of 9. Here number of neutrons given 10 and number of proton that is same as atomic number, so 9. Number of electrons also 9. So mass number is neutrons plus protons, so mass number is 19, and atomic number 9, that is fluorine, FLOURINE, right, fluorine. And this table you can complete at home. Okay children, any doubt you can ask me. Okay, so thank you, all the best.